Hello, we will be starting shortly. Hello, we will be starting shortly. You know what? I bet you there'll be sound now. Thank you very much, Walter. It's one click of a button. So this is microcontrollers with kingernorth. Unfortunately, I got to repeat a little bit of this because I just spent 3 minutes or 4 minutes talking and without any voice. Thank you, Walter. So let me show you what's going on here. So microcontrollers. I'm going to talk about this again. Hey, look at that. Working now. I'm glad. Okay, this is using subroutines in CircuitPython and Arduino. And what I was saying that you couldn't hear me, that I repeated to myself quite nicely, was the fact that we had, subroutines. Subroutines are used a lot in programming, and they are especially important when we talk about these little microcontrollers. Microcontrollers only have a limited amount of memory in them. So what we end up doing is if we want to repeat something over and over again, it's great to write a subroutine to handle it. What it does, it takes up less memory inside of that precious space inside your microcontroller. So if we use it 5 times throughout a program, I can write this subroutine once. I'll use it 5 times, which means I only need to put it in memory once instead of putting it in memory 5 times. So that's going to save it and make it more efficient. It also makes it easier when I want to edit, because if I want to make a change to that subroutine, I make it in one place and it changes it everywhere that I use it. So I only have to do it. And the other thing is, it also lets me write smaller bits of code that I can put off into a subroutine so that I can stay more organized. And that's always a good thing. So I'm happy to see that that will improve our organization as well as improve our memory utilization. What I'm showing here on the circuit diagram is what I have wired up on the board. And this is the same whether it's the CircuitPython board, the Feather M4 Express, or the Arduino Uno. They both have the exact same wiring done to them. We're taking 3 inputs from the microcontroller and we're connecting those to 3 push buttons. Those push buttons are connected back to the common lead. So there's no power actually going to them, which is really nice. The power actually comes through the input buttons, and I'll explain that. The output power goes through resistors, through the LEDs, and back to common. And then, of course, we have to supply power to our board. In our case, today, we're using the USB cable to supply the power. So that works out fine. So there's very few connections made. This is a very simple circuit. The resistors will depend on the board voltage that you're using and the type of LEDs. In the case here, I have my 3 push buttons, I have my 3 LEDs, and then tucked in here in the background, I have 3 little resistors, which are hard to see. They're actually in behind there. There's a resistor there, if I move those wires out of the way. And for this one, for the Arduino, I'm using 470 ohm resistors. When I get to the Circuit Playground version, because I'm running 3.3 volts, I'm only going to be using a 220 ohm resistor. So you just do that to limit the current flow through those 3 LEDs, and because of the difference in voltage, we have different values. So today's circuit's going to be really simple. So now that we've got the circuit there, we're going to create a sketch, and we're going to keep the sketch, and we're going to make it a simple sketch to work with. And I just want to get some basics down, and I'm going to show you how we build this up and make it usable and keep yourself organized. So let me turn off that circuit diagram. Let me turn on the Arduino sketch window. So the first thing we want to do here when we get to this is we're going to want to save this file. So let me just, I can bring that down just a little bit. There we go. That's probably better on the page. And what we're going to do is we're going to start by saving this. So I'm going to go File, I'm going to go Save As. Let's see, there's Save As, and we're going to come down here and we're going to just go into my documents. I have one here for the electronics shows that I'm doing, and there's number 11. I actually have one already built, but I'm going to create a new one here. So I'm going to create a new file, and instead of giving it by date, I'm just going to call this Sub1. Nice simple name, Sub1, so I'll be able to tell it apart from everything else. So there it is. It's called Sub1. It's up here in the corner, and we're ready to go. So the first thing we want to do is we want to add our comments at the top. So I'll just come down a couple of lines, and I'm very quickly just going to put in here Sub1 by kingernorth. Okay, and we're going to make another little comment here. This is a demonstration of subroutines. So that'll be fine. That's good enough for a to get us started. The next thing we always want to do is we want to include our helper files. So let's do that. So include any needed helper files. And you're going to like this is the fact that we just don't have any. There's none to put in here. So this is going to make life really simple for us. We're not going to need any helper files to make this work. The next thing we're going to do is we're going to declare any pins or not or but and variables needed. So that's what we're going to put in here, and we are going to need some pins. We have 3 push buttons and we have 3 LEDs, so we have 6 devices we have to declare. So let's get our pin assignments for all of those done. That's probably the first thing we want to do. So I'm just going to say integer, and I'm going to call it PB1 for push button 1, and that happens to be connected to pin 2. I know that, I've already done it, but that's where I've got it connected. It could be connected to any of the digital I/O pins. Basically, 2 to 12 could be used quite easily for all of these. So those would be the ideal choices for those. So now that we created one of those, we're going to go in here, we're going to create PB2, and that's going to be equal to 3. I put them nicely side by side to make my wiring easy. Not that I had to, it's just that that's where I decided to put them. And my third push button will go to number 4, and that takes care of my push buttons. Now I want to hook up 3 LEDs. So again, we're just going to go integer, we're going to go at LED 1, and that's going to be pin 5. If you notice, we got a nice little pattern going, they're all in a row. Integer LED 2 is equal to 6. And integer LED 3 is equal to 7. And that makes all of those connections really simple. Now, one of the things we need to do once we do this, I'm going to skip down and I'm going to jump down into this void setup area here. And we're just going to get rid of that comment in there. And actually, what we're going to do is we're going to change that to setup pin modes. So that's going to be the one thing that we have to do in here. And let's get rid of all of that extra text. We don't need that. Now, if you notice, I've indented in here. This is a routine in here. This is called void. And anytime in Arduino terminology, when you see that word void at the beginning, it is going to be the start of a routine. Now, our void loop is our main routine. Everything else is a subroutine. In this case here, the setup is a special subroutine. So we've been using them even though we don't know that we had. A void setup is something that only runs once and then doesn't run again for the rest of the time that we use it. So what we're going to do here is we're just going to set up the pin modes, because that would be one of the first things we would want to do. So I'm going to go pin mode, and I'm going to go bracket. I'm going to go PB1 for my push button 1. And what I'm going to do is I'm going to set that to input, and I'm going to call it pull up. Now there's a reason for this. And basically what it is that input pull up, we've used input before, but now I'm going to use input pull up. Input pull up connects a resistor for me. We talked about this briefly in another episode, but pull up allows me to put 5 volts on the pin. So what I need to do is, when I showed you that picture of the connections, I actually take that push button and I connect it to ground. So when I close the push button, when I press it, I'm actually going to ground the input. I'm going to take that 5 volts and change it to ground. I'm going to run it right to ground. The resistor to limit the current so we don't burn up the board is actually inside the chip itself. And by using this term pull up, it turns that resistor on to allow it to be working. So if we were to take a meter right now and connect it to that input pin, we would see there's 5 volts on there. And all I'm going to do is ground it when I'm ready. So I'm going to do this the easy way here. I'm going to go copy, just the old standard Control C, Go down to the next spot. I'm going to paste that. I'm going to paste that. And I'm going to do the editing nice and quick. Get used to doing these type of things because this will save you a ton of time. There's my 3 push button inputs. So I have 3 input buttons now. The next one I'm going to do is I'm going to create a new one, and I'm going to call it pin mode, and in this case it's LED 1. And what I'm going to set it for this time is I'm going to set it up as an output. Now, Arduino is kind of funny this way. We don't have to assign everything. I like to assign my inputs and my outputs so that I remember that I've used them. So it's always a good practice. It's not essential. It's just a good practice to go ahead and include all your pin modes for inputs and outputs. So let's copy that. And we're going to go ahead and we're going to set up now LED 2 and LED 3. So there we go. We have the basic setup done. We now have 6 devices connected to our Uno, and we've set up 6 pin modes for our Uno. So they match. And this closing brace down here, I have nothing after that, so I can get rid of that extra line. And now this is all nicely indented within the start, which is the opening brace, and the closing brace for the void setup for that subroutine. So that's created that very quickly. So now let's look at what we need to do to go into the program. And believe me, we're not done adding any variables. We're going to have to add some, but we're going to do them as we need them. So one of the things we need to do here, and we're just going to start, and I'm just going to highlight all that because I want to get rid of that particular comments that's there, and I'm going to put my own comment in. The first thing we need to do is we need to read what the state of that push button is, those 3 push buttons that we actually created. So what we're going to do is we're going to say here, read the state of the push buttons. So that's what we're going to do in our program. We're actually going to read what state everything is in. So I want to be able to get a reading and tell what state each one of these are in. So let's do that. So let's turn around, and the first thing we're going to do is we're going to set up PB1, and we'll set up 1 and test it before we move on to everything else. So now I need to create a variable. I need to create a variable called PB state. And I'm going to make that equal to digital read, and I'm going to set that to my pin that I'm required, and this is PB1. So that's my input pin. So that's what that's done for me, is done that. And that's really all that's going to do in there. But I did create a new variable called PB1 state. So I'm going to have to add that up here where it says declare any pins and variables needed up in the top of my program. Well, I do need another variable in here. So let me just go down in here, and I'm going to type in, and this is going to be a state. Now a state, when I'm looking for something, I'm only looking for 2 conditions. Even though this says digital, but I'm only looking for a single bit. I'm looking for it to be either true or false. So the easy way for me to do this is to create this not as an integer, but as a Boolean value. Now Boolean values are unique in the fact that they take up less memory. And the second thing is they also only give me 2 results, true or false. That's all. There's no in between. So this is going to be PB1 state. And since I'm going to read this value in, I don't know what the value is. I'm not going to bother assigning a value to it. I'm just going to leave it as that. Boolean PB1 state. So if I'm going to have 3 push buttons, guess what? I'm going to need 3 of these. Boolean PB2 state. And I might as well go Boolean PB3 state. And yes, I could have copied and pasted each one and then just changed the 1 to a 2 to a 3. So you can do it whatever way is efficient for you to type. That was a nice short line, so I went ahead and typed it as opposed to the longer lines. So now that I've read in the state of the push button, I'm going to leave the other 2. Even though I created their variables, I'm not going to create them yet because I don't need to. And what we're going to do is we're going to come down here, and basically what we want it to do, and this is going to be the premise behind this little program that I did, is whenever I press this push button, I'm calling that push button 1, this is push button 2, push button 3. Whenever I press push button 1, I want the red light to toggle on and off. To give you an example, there's already a program in here running, but I'm going to overwrite it shortly. But I'll show you this. I press that, the light comes on. I press it again, the light goes off. Really simple. That's all I want to do to start. So we're going to make it nice and simple. Same push button. I don't have two push buttons. It's just one push button. I push it once, it goes on. Push it again, it goes off. Nothing more than that. So we're going to build this up. So what I can do here is I'm going to have to go in here and I'm going to have to create another little part to the program. And I'm going to increase this down. And what I'm going to do is I'm going to tell it, hey, if, I'm going to use an if statement. And since I've read the state of PB1, I can look at that state now. I can look to see whether it's true or false. Now, by default, because I used pull up in my program, this one right here, I used the pull up. What's happened is there's 5 volts on that input. That means it's true. What I'm going to do is when I press it, it's going to go to ground, which means it's going to go false. So what I need to do is say when it's not true. So let's see how we do that. I'm going to type that in. For doing that, we use the exclamation mark to mean not. So not PB1. And this is going to be the state, because we're looking for the state, which is the result we got from reading the input pin. So when we're saying is when it's not true, in other words, when it's false, what I want it to do is I want to do something inside this brace here. And when I hit enter on that line, it stays indented. It indented me again by default, and it gave me both the opening and the closing. Just by clicking on the opening brace, it gave me the closing brace automatically. So I'm going to go in here, and basically all I'm going to do is I'm going to put in a real simple command, and I'm going to show you how silly this is to create this, but what we have to do is I would want to change the state. So I'm going to do it without a subroutine first, since this is the only thing I've got going in here. So what I need to do is I need to change the state of the push button. So what I'm going to do is I'm going to say PB1 state is equal to not PB1 state. So what I'm doing is I'm just telling it change to the opposite, flip. So if it comes in, what I did is I changed PB1 state. Actually, it's not PB1 state I want to do, sorry. My fault, I want to do LED1 state, because I'm going to leave that switch either on or off. So LED1 state. So what I'm going to do is I'm going to flip the state of LED1. Well, LED1 state doesn't exist yet. We didn't create it up top here. We didn't create it in our program. So guess what we're going to do? Before we go any further, we're going to create some more Boolean values. And you're going to see where this goes in a moment. So this is LED1 state. And if you wanted to copy, let's change that to the proper semicolon, not a colon. If we copy that, we'll just go paste, paste, and we'll change those. So now we have LED1 state, LED2 state, and LED3 state. So what I'm doing is I'm flipping the state of this. Again, I don't know the state. It doesn't really matter what it is at this point. But now what I have to do is I have to write that to the LED itself. So what we're going to use here is we're going to have to use a digital write command. We use digital read to get the input state. We're going to use a digital write to set the output state. So we're going to go digital write, and we're going to tell it what pin, and this is LED1. And we're going to set it according to whatever LED1 state is. So if its state is true, it'll turn on. If the state is false, it will turn off. And that's really as simple as that gets. And the last thing I want to add in here, just something that we're going to find that we're going to need somewhere when we press the push buttons, is we need to add a slight delay. This thing is working so fast and cycling through and scanning through the program so fast, if I don't put a delay in here when I press the push button, it'll go on and off hundreds of times a second, if not more. And that's just way too fast. I can't predict when I let go what it'll be. So I'm going to give myself about a half a second delay to let go of the button. So that way when I click it, I know if I hold on to it too long, it'll start flashing. And it'll actually flash every half a second. And we'll test that to see how that works. But what we've done here is we've created a nice little simple program now. So this is our loop. We read the state of push button 1. If the state of push button 1 is false, then we take the LED state, we flip it to its opposite state, and then we write that to the LED, that condition, either true or false, and that'll either turn the light on or turn the light off. If we want to make sure that this is working, I'm going to hit verify. Before I try to download it, it says compiling down here at the bottom. And it's going to get through there. It's thinking and it's just checking. And it says done compiling. This bottom bar didn't change orange. I didn't get any warnings. So as far as it's concerned, it should be okay. So let me go to Tools and make sure I'm connected to my port. It says COM10 Arduino Uno. Everything looks good here. So let me go ahead and upload this to the sketch. So if we look down on the board right now, it says uploading, and it's already done. It's quick. There's not a lot to upload. The light flickered so fast we didn't even see it. If I press the button, the light comes on. If I press the button again, the light goes off. On, off, on, off. It works really well. Now none of these other buttons do anything because we didn't write to any code for those. But this one is configured for the red LED. Looks simple so far. We really don't need a subroutine to do this, do we? But I'm going to make it more interesting, and we're going to use a subroutine. So what I'm going to do is I'm going to show you how to change this to become a subroutine. So I'm going to very simply now, I'm going to come down here, and I'm going to come down here underneath where void loop ended, add a couple of lines in here, and I'm going to create a new subroutine. So let me put a comment in here. This is going to be my red LED. Actually, I'm just going to type it normal. Red LED subroutine. So we're going to create a routine here for the red LED. To do that, I start by typing in the word void. That tells me I'm going to create my own subroutine now. And I've done this after the loop. And this is important in Arduino. It needs to be after the loop. It actually reads information backwards and then executes forward. And what happens here, it reads through the void section and has to load all those into memory, all these subroutines into memory, before it can run the setup and the loop. So what we're going to do here is we're going to put in void, and I'm going to put in one called red LED. And I'm just going to put my brackets, and I'm going to start with an opening brace and hit return. Now it looks just like any of the other void loops. There's void setup, opening brace, closing. Here is void loop, opening brace, closing. Void red LED, opening brace, closing. And I'm going to put my code in between. And what I'm going to do is I'm actually going to go in here and I'm actually going to copy this code. And I'm going to put it in here because that's what I want it to do when it's in there. And I actually threw in a couple extras because it's already got the spot. But basically what I want it to do when it comes into the red LED, I want it to change the state of the LED, and I want it to then do a digital write. And that's what it's going to do. So we're going to see if that works. Up here, in order to call it, I need to change these two lines now. I'm going to get rid of those two lines. And to call this subroutine, all I do is type in red LED, bracket, bracket, and a semicolon. Red LED function tells me I want to go to the subroutine. So this is what's calling. So from here, as my program executes through this loop, it's going to read the digital input. It's going to come down here. It's going to take this, it's going to come down here, and it's going to figure this out. And I'm going to go ahead and I'm going to flip it. Let's see if this works. So I'm going to go ahead and tell it to upload. We're going to test it. This is actually a slight variation from my existing program, but I think it'll work fine. But let's test it. I press my button, the light came on. I press it again, it goes off. I press it again, it goes on. If I press it again, it goes off. Now I said I'd show you what happens if you press it and hold. So let me press and hold the button, and you'll see it flat blinks every half a second. Because every half a second it goes in, reads it, and then has to go back and put it back out. So you're going to tell me right now my program got longer even though I created a subroutine. But again, I've only used it once. Now, what we're going to do is we're going to expand on this program and we're going to make it bigger. So I did push button 1 here. Let me copy all of this in my main loop. I'm going to come down here and I'm going to create another spot and I'm going to paste that. Now, instead of looking at the state of PB1, I want to look at the state of the second push button. So we need to bring that second push button state in. So let's do that. Very simply, I'll just copy. I use a lot of copy and paste here. And I'm going to check the state of PB2. And there it is. So now here's my second push button. So this is my first push button. This is my second push button bringing the data in. Now I'm going to come down here and instead of turning on the red LED, what I could do is I could turn on a yellow LED. Seems pretty simple. Let's go down here and go down to the red LED subroutine. Copy that whole thing. We're going to create subroutines quickly here. And we're now going to make this a yellow subroutine. So there, I've done there, and now change everything here to 2s because everything associated with the yellow, and then I'm using the second push button. Oop, there we go. And you're going to see where this goes shortly, but it's not quite there yet. So now I'm reading both push buttons. I'm checking their states. I'm going to change the color that lines up with that push button. So let's go ahead and upload that. Now we are building to a larger session here. So now that that's done, I can press my red and I'll press my red again. And it works just like before. I do the yellow now, my yellow comes on and off. Well, let's turn the yellow on and let's press the red. I can now have them both on. If I press the button on the yellow, it'll go out. If I press the button on the red, it'll go out. Okay, that seems all right. Let's change this up a little bit now. When I press the first button, I want the red to go on or off to the opposite state of what it is. When I press the second button, let's make both the red and the yellow change state. This is where subroutines start to come into it. So what I've done here is I've created in my program, in my sketch, as Arduino likes to call it, I've created one for doing the red light, for flipping the state of the red light. I've changed one for flipping the state of the yellow light. Well, when I press this button here, let me add another line in here for push button 2. Let me also run the red LED subroutine. That's the only change I made. I added one line in here and I'm going to save the code. And I'm going to write it to the processor. And it's done. I'm going to press the red LED button. It came on. When I press the yellow one this time, both of these should change state. So what should happen is the red should go off and the yellow should turn on. And it did. Now if I press the red will come back on. And if I press the yellow, these are both going to change to the opposite state that they're currently set to, which is going to turn them both off. I can turn them both on. I can turn one off, flip them. So I can play around with the buttons now. The first button only affects the red. The second button affects the yellow and the red. Well, let's add this third button to make things more complicated. So what I'm going to do here, this is pretty straightforward still. I'm going to copy this part of the program in my main loop. I'm going to copy that. And I'm going to put in what I want it to do if I press the third push button. So we're going to have to look at the button 3 state. And this time what I want it to do is I want to not only turn on the red LED, flip the yellow LED, but I also want it to flip the green LED. So we're going to create another subroutine here called green LED. I'm going to come down here to the bottom. I'm going to copy my yellow LED. Come down here, add this, and I'm going to change everything here to green now in this section. So this is going to be my green LED subroutine. Green. This is going to be for the third LED, so now we have to make sure that everything says 3. And way up here at the beginning of this loop, I need to read the third push button. So let's copy that, paste, and let's make sure that's set up for number 3. So if we've done this right, if all this is done correctly, what we should see here happen now is when we press this is in our main routine, if we press push button 1, the red will change state. If we push button 2, the red and the yellow both change state. If we press push button 3, the red, the yellow, and the green change state. And that just means flip them to whatever they weren't before. So let's go ahead and upload that. So this is the uploading. And it's done. I can see that one still works. If I press this, they change state. Both of these change state. If I press the third button now, everything changes state. Oops, let's get back here. If I press the second button, only the red and green. If that one changes, they're all on. If I press the third one now, what should happen to all 3 of my LEDs? Well, they should turn off. And they did. Turn those 2 on. I can change it. And I can sit here and do this all day, and that same principle still applies. So I can keep playing around with this and make it work that way. So here I've done something very simple. Instead of having in my main code, let's go look at this in my main loop. Instead of having to write those lines for the red LED 3 separate times, all I did was have to call it each time I wanted to use it. For yellow, I used it twice. I only have to write the code in one place. I don't have to repeat it. So this, it saves me a huge amount of time. Let's add some comments to this thing so we can make some more sense out of what's happening here. So very quickly, let's start at the top and work our way through, and we'll add comments as we move our way down through the program so that we can see exactly what's happening. So we start out with here, this is just a program called Sub1 by me, and it's just demonstrating subroutines. So include any helper files, declare any pin, and no helper files needed, by the way. Declare any pins and variables needed. We created the 3 push button pins. We created the 3 LED pins. And then we had to create 6 Boolean values. Now these are all dealing with state. So these are the states of the push buttons and the states of the LED. So that's what I've done there. In our void setup, we needed to set up the 6 pins. Now 3 of these are going to be set up by default, 3 are not. So what I'm going to do is I'm always going to put in, or I try to always put in, all of my pins that I'm using. That way I don't forget that I've used them. I can look here and say, oh, that pin assignment's already done. Don't try putting it in here again. In my loop is broken down into a few steps, and this is where we have to add some comments into here. So what we're going to do is we've got in here, so the first thing we do is we read the state of the push buttons. So every time we come through this loop, and it's going to cycle every few milliseconds, is we're going to come in here, or faster, actually, and what we're going to do is we're going to read what position these 3 push buttons on the board are in. Did I press them or did I not? And what they're doing is they're all true right now because they're all input pull-ups. If I press the button, they become false. So that's the key when we've pressed the button, is when the input is false. So this first one here, when we get down to this one, this red LED, and what this is, the purpose of this little block of code is to toggle the red LED. And that's exactly what that does. Whenever I press button 1, I read that press, it pushes and it flips the state of the red LED. When I get down to the next one, I'm going to toggle the red and yellow LEDs. So this time when I press the second button, I can toggle both LEDs at the same time. And again, they're going to go to whatever the opposite state is that they're currently using. The next thing that I'm going to do is I'm going to toggle the red, yellow, and green LEDs. So that's what I've done in here. So that's what's happening in here. And then very simply, to let me know what I'm going to do in here, is I'm going to add a couple of comments here. And I'm just going to add the simple comment that's going to say flip. That flips the condition, the state of the LED. And then what I've got to do is I've got to write that. So I'm going to write that condition back to the LED to make it set. And of course, it's going to be the same for each of these. Let's get the right number of spots going here. Make that flip and right. And finally on this one, it's going to be the same thing. We don't want to hit enter there. We want to move down. There we go. And we're going to write. So there we go. We have now a commented block. And in fact, I'll get rid of that extra space since I don't need it. I have a nice, neat program that I can follow. Start with some comments, put in any helper files, declare my variables. When I get to my any routine, this is my void setup routine. This is going to assign my pins. Do any other things that I need to do at the beginning, like turn on the serial monitor if you're using that for print statements. But I indent everything within that routine to make it nice and neat. Then I go to void loop. Again, everything is indented all the way down to the final brace, which is part of that loop. But I read the state of the push buttons. Then I do something. If the push button is false, do something and delay. That's just to allow me to let go of the button. Gives me time to let go of the button. We're going to do the same thing for the toggle, the red and the yellow, except this time we're going to call up two subroutines. And in the third one, when we press the third button, we call up the red, the yellow, and the green subroutines. So these subroutines are handling all the flipping and the writing for us. And all I've done is say when I want it to run. So in the case of the last one here, PB3, which you can see on the screen at the top of this at the screen, it's going to run the red routine, which is going to flip the red. Then it's going to come back and run the yellow routine, and it's going to flip the yellow. Then it's going to come back and run the green routine, and it's going to flip the green. So there, very quickly, I'm able to use the red routine for all three of the buttons, the yellow routine for only the second and third buttons, and the green routine only on the third button. But I've done it very efficiently. So we can see all of this is working, and we can actually play with the buttons and make the lights go on or off to our heart's content. So now we've created that. So that's how a subroutine works. Now there are more complex subroutines once you get used to doing the simple ones like this. And you can actually send variables to the subroutine and get variables back from the subroutine. That's especially important if you want to do math with it. And where that comes in handy is possibly when you're doing something like mapping that we did way back when we dealt with a potentiometer on there. We could map, if we had multiple potentiometers, we could map in the raw value, bring back the mapped value. Especially if they're all working the same, it's just that we needed to do it multiple times. So that's what a subroutine does. It's anytime we want to do something multiple times. So hopefully that answers your question on what does a subroutine do in the Arduino. So let me move that one out of the way. And let me bring this one in. This one, let's get it under the camera. This is set up the same way. So let's have a look at the program that's in this one here. So I'm going to shut off my Arduino screen and let me turn on my Mu editor for CircuitPython. I already have this built in the background. Again, let's demonstrate it. I press the first button, the red light comes on. I press the second button, both flip. The third one, they all flip. So I can sit here and do this until I finally get everything back to the off position if that's what I want. Again, I wired the 3 yellow wires to 3 inputs. I wired the 3 green ones to 3 outputs. I took my 3 grounds from my push button and wired them back to ground. And I also put in 3 resistors, and those are 220 ohm resistors in this case because this is a lower voltage. Even though this is 5 volts coming in on the USB, this board works on 3.3 volts primarily. And I am connected to the 3 volt lead on this side. So that's normally my normal voltage. That's what my pins are going to output by default. So that's the reference. So let's have a look at how I built up this program. So again, I have my comments at the top. I use the same format. I do an include file. In this case, because it is CircuitPython, nothing preloads to save on memory. So I needed to load in the board information. I needed to put in time for my delays. And I needed to bring in digital I/O since I'm going to tie to the digital I/O pins. So I brought all those in. They already preload in the Arduino world. They don't preload in the CircuitPython world. I'm going to create any objects or variables. Well, this one here looks longer, and it is by lines, but it's doing the same thing, except that I do here in CircuitPython what we did in Arduino between setting up the variables and doing the void setup, doing that I want to run this once business. I do it all here. I do it in one section here. This is just the way this is created. So for each push button, I have push button 1 equals, and it's digital I/O dot digital input output, and I give it my board number, and this is board digital pin 10. That's where the input is connected. Hey Bruce, if you press and hold the red button, will it flash? Not at 1.5 second intervals, but actually there's only a delay on each individual button. There, I'll show you there, it flashes in half a second intervals, 0.5. Same thing goes if I'm doing 2, because the half second delays are actually in the push button circuit, not in the LED part. So thank you for doing that. So yeah, we don't actually read it a half a second per LED, it's just a half second per push button. Okay, so let's get back to the program here. The second line of this push button 1 is I need to set the direction. And I'm going to set it as an input. And then this is the third line because I want to use pull-up. I'm going to set it as a pull-up. Again, it applies the voltage to the pin so that all I need to do is ground it. So that's what those 3 lines do there. It sets the pin number, sets the direction, and sets it whether it's a pull-up or not. If I don't put anything in there, it will be powered down and it'll be looking for 5 volts to make it true, or looking for voltage to make it true. And then I did the same thing for push buttons 2 and 3. So basically I created one, copied and pasted, and just changed the numbers where I needed to change the numbers. The LEDs are down here. They only require 2 lines. One is I create the object LED 1, and I create it and I attach it to a pin. And then what I do is I set the direction to this, and in this case it's set as an output as opposed to an input. So I've actually taken care of that and done that. And again, I do that for the 3 of them. That's all there is to that top portion that we did in Arduino. What we did in Arduino, we actually created the pins, the variables, and then we also defined in the setup the pin modes. That's all done there in that first little steps. This is where things differ a little bit. When we do Arduino, we put the subroutines after the main loop. In CircuitPython, we put our subroutines prior to the main loop. So, and this is where it is here. So this doesn't include any subroutines needed when we're doing with CircuitPython. It's a little different format because it's designed to read into memory a little differently. And what I've done here, we start subroutines in CircuitPython with the term DEF for define. It's a definition, actually. It's a definition, not define, definition. And here and then I have the subroutine name. So I have red LED, just like I did in the other one, same routine name as red LED. And then I've got LED1 value, so that's reading the value in. I'm going to set that value equal to not, instead of an exclamation mark like we used in our Arduino for setting nots, for changing state, we actually put in the word not, and it goes bold, and LED value. And what that does is read, flip, and write all in one step. So what we did in 2 lines and the other where we had to flip it and write it, is we actually, and we didn't have to read it in. You could read it in as well, but we actually only flip it and write it. And here we read, flip, and write all in one step. So it does it all at one time. Just makes life a little bit easier. And we do that for the 3 subroutines. So here's the code now to make this work. While true is your main equivalent to void loop in Arduino. So what we have here is we have toggle the red LED value. If not, push button 1, then run the subroutine red LED, which is up here. And it says flip right the red LED, then time sleep for a half a second. Yellow, the second button does the red and then does the yellow, and the third button does the red, the yellow, and the green. Exact same thing. Let's do a little comparison. We've seen the board work. So now, let me show you the code side by side and let's compare them. So I'm going to take this up to the top. I'm going to bring my Arduino back up on the page. And all I'm going to do is I'm going to move it over so that these are side by side now. So let me take the Arduino to the top as well. So in Arduino, we start out with comments. I start out with comments in my CircuitPython. I include any helper files needed. I included these helper files right here. So I did those. I included the helper files. There aren't any needed in the Arduino side of things. Declare any pin values needed. Well, I'm doing that right here. So let's bring that up. Declare the pin values, declare the types of data, and then declare their modes. So let's go over here to this one. In this area here, I actually do all the same things. I set my pins, I set the direction, which is the mode, and I set them to pull up if they're inputs, and just I set the pins and set the direction to output if they're outputs. So all of this code here that you see starting basically on rung, well, including the comments, rung 10 down to rung 27 in CircuitPython, is the same as from rung 6 down to rung 28 in Arduino. So it took a few extra lines, but a few more letters in CircuitPython. The next thing is where they differ. The two set up differently here. After we do all that setup information at the top, where we're setting the pin modes and the directions, Arduino jumps right into the loop. CircuitPython jumps into the subroutines. So they flip it on its head. So that's where the two of them different in structure going down. Up until then, they were pretty similar. But now what happens is we actually change where we define the subroutines. So let's go look at the Arduino subroutines. We're going to scroll down here, bring them up on the page. And in fact, we'll bring that down kind of even on the page. There. So what we have on the right-hand side, we're showing you the CircuitPython with rung 30 is the beginning of that loop. In fact, with the instruction or with the comment, it starts on rung 29 and goes to rung 31. That is the same information that happens from rung 56 to rung 60 in Arduino. So it actually took less rungs to write in CircuitPython. Again, same thing for the yellow subroutine, and then the green subroutine is the same thing. So they're all built the exact same way. So once I proved one, I just keep building on it. And then finally we get into the main loop. So when we're into here, the loop starts at rung 40. On this one, the main loop starts at rung 33. Actually, this one would be 39 because I include the code. So this is my main loop. In here, all I do is I don't have to read. I had to start by reading each of the input pins. I don't have to do that in CircuitPython. It will do that when I call for the value. It's an automatic read. So down here, I've done this, and then what I do is I look at the 3 push button states. So basically what I've done is this reading of the push buttons becomes part of this line here. And then inside, basically inside, I should get back into here. Let me get back into that loop. There we go. So we can see it better. This is the 3 pins I have to read. Here is the toggle. So I say if push button is false, run the red LED subroutine and delay for half a second. When I get in here, I said if not push button 1 value, in other words, if the push button value is false, run the red LED and pause for half a second. Exactly the same principle. Doesn't matter whether I'm running it in which language, Arduino or CircuitPython. And it's the same for all 3. All 3 basically work the same way. And that's exactly how these 3 work, and that's exactly how these 3 work here. So they're similar. It took less rungs. In fact, this one took me 72 rungs in this particular language using Arduino. In here, I used 55 rungs. So it took me less rungs in CircuitPython, but that just happens to be because of the way they're structured. That's not that one is doing something the other one can't. They are both doing the same thing. And as we saw on my boards when I started, whether I'm running the Arduino board or I'm running the CircuitPython board, let me just turn off the Arduino code there so you can see it. Doesn't matter which board I'm running. When I press my buttons, they do exactly the same thing in both programs. It's totally non-program style related. I can do the same thing in Arduino that I can in CircuitPython. It's just done a little differently. So the choice is always yours on what you want to do. So I don't know if you guys have any more questions. I saw Bruce's one question there about the timers. If you look at my code, I'll just show you that in the program code here. The timing values are in the push button segments and not in the subroutines. So the subroutines execute very quickly with just a single pause based on each button. Okay. And that's basically what subroutines are. That's what subroutines are all about. So it's actually pretty neat on what we can do with subroutines. We can actually save ourselves a lot of room. This is much more organized than if we had to write that code and keep repeating it everywhere that we wanted to use it. So anytime you're going to repeat code, by all means, create a subroutine for it. You'll actually find out what it's good. And if you're doing it once, you write it in the code like we did when we started doing it with the Arduino today. We wrote the code once, we tested it, and then we created a subroutine to replace it. And then we just kept going from there on and on and on and on and on. Well, I hope this has been interesting to you. I hope this helps you with your programming to get you organized, to maybe make you a little more efficient, and to be able to work through everything and get it working the way it should have. Video is happier this week. I think that was because I did some settings on my computer. I apologize for the lack of sound for the first 3-4 minutes. That was me not pressing a button on the screen. And other than that, I think we're in good shape. We're going to be back with episode 12 next week. And I'm going to go into more information. You got to see them very briefly on the very first episode. I had some NeoPixels connected to both boards, but I was mainly introducing the boards at that point. I wasn't really talking about the NeoPixels very much. So we're going to go into a little bit deeper information about NeoPixels next week. And we're going to do that, and we're going to show how to hook them up when you have more than a couple of NeoPixels, what good practices are, and it doesn't matter whether you're using the which board you're using, whether it's Arduino or CircuitPython, one of the CircuitPython boards. Good practices are good practices. So we'll show you how to hook those up, how to wire them up, how to make them run a little more efficiently, and we'll just play around with some alternative ways of connecting them and getting some ideas on how we can work with NeoPixels to a bigger extent. So that'll be week 12. Episode 12 is going to deal with NeoPixels. We're going to go with the light show. And I'm going to see if I can play around this week And I might get myself a little diffuser and put it in front of the NeoPixels so I don't blind out the camera every time I turn them on. All right? So, hopefully you enjoyed yourself. Hopefully you learned a little bit and you saw some differences between the two. Now you want to go and play, Walter. Well, that's good. That's the idea. I hope you're inspired. I hope Bruce is too. Bruce is working on some pretty advanced subjects. I know he is. I'm hoping to see his boat sometime later this year. I want to see his boat in the water. That's got some our controller boards in it and a few extra features. He's a little more advanced than you are, Walter, at this point. But you'll catch up, Walter. You'll do all right. Anyways, thanks very much. We'll see you all next week, and we're going to do episode 12, like I said, on NeoPixels. So tell your friends, get them out here. That's sure to be an enlightening subject. Yeah, I know that's a pun. All right, until next week, take care and enjoy. Don't forget, you can follow me on Twitter at kingernorth, and also subscribe to my YouTube channel.